Ever use a smartphone? Or rely on like super secure online transactions?
Oh, yeah, definitely.
Well, you might have a Brooklyn-born physicist to thank for that.
Interesting.
Nathan Rosen.
Okay.
And in this deep dive, we're going to uncover who he was and why his work is relevant to you, the listener, and how seemingly abstract physics from the 1930s is woven into the tech we use every day.
I'm intrigued.
We've got a stack of his research, biographical info, and even some like modern day applications to explore.
Sounds like we've got our work cut out for us.
Yeah. But first, we need some context.
Okay.
So,
Rosen was working right at this time when physics was undergoing a massive upheaval, the kind that redefines how we see reality, itself.
wow.
The early 20th century was when quantum mechanics emerged, and it challenged everything, really everything that classical physics held dear.
So like Newton's apple falling from the tree was suddenly out the window?
Pretty much. Yeah, it was a time when scientists were realizing that the subatomic world, the realm of atoms and particles, operates by a totally different set of rules.
Okay, so down there things get a little weird.
Yeah.
But how did Rosen get involved in all of this?
Well, imagine this. It's the 1930s.
Right.
Einstein's theory of relativity has already blown everyone's minds, changing our understanding of gravity and the cosmos, right?
Right.
But now quantum mechanics is coming onto the scene, suggesting that things can be in multiple states at once, properties are intertwined in bizarre ways, and our Brooklyn boy, Nathan Rosen, born in 1909, ends up collaborating with Einstein himself at Princeton right in the thick of it.
From Brooklyn to Einstein's sidekick.
Exactly.
That's a pretty wild ride.
Yeah.
So what did they work on together that's so important for us to know today?
Well, one of their most famous collaborations resulted in a paper that still has physicists debating. It's called the EPR paradox. EPR, yeah. Published in 1935, it questioned whether quantum mechanics was really telling the whole story about reality.
All right. Got to make sure I'm following along here. This EPR paradox hinges on the idea of quantum entanglement, right?
Got it.
Where two particles are linked so tightly that knowing something about one instantly tells you about the other, even if they're light years apart.
You got it. It's like they're connected by an invisible thread.
Wow.
Einstein called it spooky action at a distance because it seemed to break the rules of how information could travel.
Wait, so how's that even possible? Does that mean things can communicate faster than the speed of light?
That's exactly what bothered Einstein.
Yeah.
See, the idea of locality was central to classical physics, right?
Right.
It means that an object can only be influenced by things in its immediate surroundings. Entanglement seemed to violate this, implying that somehow these particles were influencing each other instantly across vast distances.
Whoa, so it wasn't just some theoretical debate. This was like a fundamental assumption about how the universe works. No wonder it caused such a stir.
Exactly. And this paper wasn't just some intellectual exercise. It set off decades of research trying to understand the nature of reality itself. And get this. It even laid the groundwork for things like quantum cryptography, which we'll dive into later.
So spooky action at a distance could actually help us keep our online secrets safe.
Exactly.
That's pretty wild.
Yeah.
But before we jump ahead, Rosen and Einstein didn't stop there. They also came up with something about wormholes.
They did, and this is where things get really, really mind-bending, even for someone who studies this stuff.
Okay, full disclosure, I've seen Interstellar.
Okay.
We're talking about those theoretical tunnels through space-time, right?
Okay.
Did Rosen and Einstein actually figure out how to build one?
Hold your horses.
Okay.
The Einstein-Rosen bridge, as it's formally known, is still theoretical.
Okay.
But Rosen's work, building on Einstein's theories of relativity, opened up this incredible possibility, a connection between the large-scale structure of the universe, governed by gravity, and the tiny world of quantum mechanics.
So two of the biggest ideas in physics finally starting to talk to each other.
Precisely. And this was a huge step towards what physicists now call quantum gravity, the holy grail of trying to unify those two seemingly incompatible realms.
Okay, but even to begin to wrap my head around something like a wormhole, you'd need some serious math skills, right?
Absolutely.
Was Rosen a bit of a math whiz?
Oh, absolutely. Rosen was exceptionally skilled at taking complex physics and expressing it in the language of mathematics. And this wasn't just for fun.
Yeah.
In quantum mechanics, you're dealing with probabilities, uncertainties, things that are way easier to describe with math than with words.
So it's like he was creating a model of how reality operates at the quantum level using math as his toolkit.
Exactly.
But did he do anything specific with those skills that we see impacting the world today?
One of his major contributions involved tackling one of the most famous equations in quantum mechanics, the Schrödinger equation. This equation basically describes how the state of a quantum system changes over time, but it's super complex.
Yeah.
Rosen's work helped physicists understand what the solutions to this equation actually meant for real physical systems.
So he wasn't just crunching numbers. He was figuring out what those numbers were trying to tell us about the universe.
Exactly.
Okay, so you've got this picture of Rosen.
Yeah.
A guy from Brooklyn who ended up working with Einstein, tackles these mind-bending paradoxes and dabbles in the math of wormholes.
Yeah.
But I'm still waiting for that aha moment, that connection to how this stuff impacts me today.
Well, get ready, because that's where Rosen's legacy gets really interesting.
Okay, I'm on the edge of my seat. Tell me more.
Remember that spooky action at a distance, quantum entanglement?
Yeah.
Well, Rosen's work on that laid the foundation for something called quantum cryptography.
Okay.
Imagine being able to send messages that are completely unhackable.
Unhackable?
That's the promise of quantum cryptography.
How does that even work?
It all comes down to the weirdness of entanglement.
Mm-hmm.
If you try to intercept a message encoded using entangled particles, you inevitably disturb their state. It's like trying to eavesdrop on a conversation by cutting the phone line.
Okay.
The act of eavesdropping itself alerts everyone involved that something's wrong.
So it's not just about encrypting the message. It's about making the message itself tamper-proof.
Right.
That's mind-blowing. But is this really happening, or is this still science fiction?
It's already happening. For example, China launched a satellite called Mauritius that uses entangled photons to create a secure communication link. They've even used it to hold a video conference between Beijing and Vienna with unbreakable encryption.
Whoa, so this isn't just theory anymore.
No.
It's real-world tech, and it's all thanks to Rosen's work on something that seemed totally abstract back in the 1930s.
Exactly. And his contributions go way beyond just quantum communication. Remember how we talked about his mathematical prowess and his work on the Schrödinger equation?
Yeah.
Well, that's absolutely crucial for another emerging field. Quantum computing.
Okay, quantum computing. I know it's a big deal, but I'll admit I'm a little fuzzy on how it actually works.
Sure.
I know there's something about qubits and superposition, but could you give me a quick refresh?
Sure. So regular computers use bits, which can be either a 0 or a 1.
Right.
But quantum computers use qubits, which can be 0, 1, or both at the same time.
Both at the same time.
Yeah. Think of it like a spinning coin.
Okay.
Until it lands, it's both heads and tails simultaneously.
Right.
That's superposition.
Okay, I sort of get that. But why is that so powerful? What can these qubits do that regular bits can't?
Because they can be in multiple states at once, qubits can explore many different possibilities simultaneously.
Mm-hmm.
It's like being able to run millions of calculations at the same time on a single computer.
Wow.
This opens up the possibility of solving problems that would take classical computers millions of years, maybe even longer.
So we're talking about a completely different way of computing, not just like a faster version of what we have now.
Exactly. And Rosen's work, especially his contributions to understanding the Schrödinger equation and the mathematics of quantum systems, is essential for building and controlling these qubits. Think of it like this. Rosen provided some of the essential tools and blueprints that are now being used to construct these mind-bogglingly powerful quantum computers.
So Rosen's not just the entanglement guy. He's also laying the groundwork for this whole other technological revolution. It's starting to feel like his fingerprints are all over the future.
That's a great way to put it. And it's not just about the technology itself. Rosen's work also had profound implications for our understanding of the universe at a fundamental level. His research pushed the boundaries of what we thought we knew about reality, about the very nature of space, time, and information.
I've got to admit, all this talk of entanglement, wormholes, and quantum computers is pretty mind-bending. It's like physics is trying to outdo science fiction these days.
Mm-hmm.
But I also keep thinking back to that EPR paradox and how it challenged some of our most basic assumptions about the universe. Did Rosen ever dive into the philosophical implications of his work?
He did, though he was primarily a mathematical physicist.
Okay.
Rosen was acutely aware of the broader questions his research raised about the nature of reality, the role of the observer, and the limits of human knowledge. While he may not have provided all the answers, his work certainly sparked a deeper conversation about these fundamental mysteries.
It sounds like he was bridging the gap between science and philosophy. showing how these two seemingly separate fields could actually illuminate and enrich each other.
That's a wonderful way to put it, and I think it speaks to the breadth and depth of Rosen's intellectual curiosity. He wasn't just interested in solving equations, he was interested in understanding the deeper meaning and implications of those equations, about what they could tell us about the nature of reality itself.
For someone who made such significant contributions, I get the sense that Rosen wasn't really seeking the spotlight. He seemed more interested in the pursuit of knowledge for its own sake.
Absolutely. Rosen was a humble and unassuming person dedicated to unraveling the mysteries of the universe. He didn't crave fame or recognition. His passion lay in the elegance of mathematical equations, in the beauty of physical laws, and in sharing those discoveries with the world.
That makes his impact even more impressive, doesn't it? It wasn't about ego. It was about a genuine desire to understand the universe and to inspire others to join him on that journey of discovery.
Exactly. And in that sense, I think Rosen embodies the true spirit of scientific inquiry. It's about collaboration, the willingness to challenge assumptions, and the humility to recognize that there's always more to learn.
Well said. But I have a feeling our listeners might need a moment to catch their breath after all this mind-blowing information. Maybe it's time to move on to Rosen's lasting legacy and what his work means for the future. Ready to wrap things up?
I'm ready when you are. It's been a truly fascinating journey exploring the life and work of this remarkable physicist.
So we've gone from Brooklyn to Einstein, from spooky action at a distance to unhackable messages, from wormholes to the mind-bending world of quantum computing. It's incredible how Rosen's work, often rooted in the most abstract theories, has had such tangible ripple effects on our world.
What's truly fascinating is how Rosen's contributions weren't isolated incidents. He had this knack for connecting the dots, finding those unifying principles that run through seemingly disparate areas of physics.
Right. Like with wormholes, he was trying to bridge Einstein's relativity with the wild world of quantum mechanics. That's a pretty big swing, even for a genius.
It was, and that pursuit of a unified theory, one that could explain the universe from the tiniest particles to the largest cosmic structures, was a constant theme in Rosen's work.
And it seems like his mastery of math was a key part of that. He wasn't just playing with equations. He was using math to unlock a deeper understanding of how the universe operates.
Absolutely. Rosen's mathematical prowess wasn't just about crunching numbers. It was about translating the complexities of physics into a language that allowed for precise exploration and prediction. His work provided a framework, a set of tools, that countless physicists have built upon ever since.
It's like he was laying the foundation for a whole new way of looking at reality, a way that embraced the strangeness of quantum mechanics and the power of mathematical reasoning.
And those foundations have led to some truly awe-inspiring advancements. We've already touched on quantum communication, the ability to send information that's fundamentally secure thanks to the quirks of entanglement.
Yeah, it's still kind of blowing my mind that this is actually possible. Thanks to Rosen, we might be entering an era where unhackable communication is the norm.
And then there's quantum computing, which has the potential to revolutionize countless fields. Imagine designing life-saving drugs in a matter of days, not years, or creating entirely new materials with properties we can barely fathom today. That's the promise of quantum computing.
It's almost overwhelming to think about the possibilities, but it's also a testament to the power of basic research. Rosen's work reminds us that sometimes the most profound discoveries come from pursuing knowledge for its own sake, even if the practical applications aren't immediately obvious.
Precisely. Rosen's journey underscores the importance of investing in scientific curiosity in those fundamental inquiries that might not have immediate payoffs, but can ultimately lead to extraordinary breakthroughs that reshape our world.
It's that long-term vision, that willingness to delve into the unknown that often yields the most unexpected and transformative results. Rosen's life is a reminder that the pursuit of knowledge is a journey, not a destination.
Beautifully put, and that journey, as Rosen demonstrated, is often filled with unexpected twists and turns. It requires a willingness to challenge assumptions, to embrace new ideas, and to constantly push the boundaries of what we think is possible.
So as we wrap up this deep dive into the world of Nathan Rosen, I think it's important to acknowledge not just his scientific contributions, but also the philosophical questions. His work raised the EPR paradox, especially forced us to confront some pretty fundamental mysteries about reality itself.
Absolutely. Rosen's research challenged our understanding of what it means to observe, to measure, and to know the universe around us. It sparked a deeper conversation about the nature of reality, the role of the observer, and the limits of human understanding. While we may never have all the answers, Rosen's contributions have undoubtedly illuminated the path of inquiry.
It's like he expanded not only our knowledge of the universe, but also our appreciation for its mysteries, for the profound questions that science continues to grapple with.
Yeah.
He reminded us that the more we learn, the more we realize how much we still don't know.
Couldn't have said it better myself. Nathan Rosen was a true pioneer, a visionary who helped shape the scientific landscape of the 20th century, and his legacy continues to inspire and guide us as we venture further into the uncharted territories of the 21st century.
So to all our listeners out there, let Rosen's story be a reminder that curiosity is a powerful force. Never stop questioning, never stop exploring, and never stop marveling at the wonders of the universe. And if you're hungry for more on Nathan Rosen and his remarkable contributions, be sure to check out the resources we've listed in the show notes. Until next time, keep those minds engaged and keep diving deep